everyone, I'm Kylie and this is my Physics 1 Lab 2 presentation. So the introduction to this lab, the purpose of this lab is to measure the position of an object when dropped from rest at a given height and compare the observed position with computational models involving gravity alone and then with gravity and drag. So a little preview into the results is the model that excluded drag was more accurate representation of the recorded values, but in theory, it should have been that the model that included drag was more accurate. So possible reasons for this will be discussed later in the errors section. So some of the formulas and laws that go into this is Newton's second law. The formula for Newton's second law is used in the creation of the computational models for this lab. The law helps us identify the relationship between net force and how it is equal to the change in momentum over change in time. This law is also the basis for the velocity update formula and the position update formula, which is important for the computational models further in this lab. And those are shown in the picture below in green, and then we also use formulas for gravitational force and drag, which is shown in the bottom three equations. And the setup of the experiment, so in this lab, a rolled up washcloth was tied together with a hair tie, and that is our system. Gravity, drag, and the floor are our surroundings, along with the air. The observed position is recorded in Tracker. The two computational models are also created in GlowScript, one with just gravity and one with gravity and drag. Our initial position is 0x, 0y, and 0z. Our assumptions is that gravity and drag are the only forces and that the washcloth started at the exact origin with zero velocity. And here's a picture of the setup. So we have the origin set as centered as I could get it on the washcloth. Of course, that could lead to some potential errors in the future. And here are the coordinates that were recorded once I dropped the washcloth. And then here's the code that I set up to find the velocity involving gravity. So as you can see, I changed the starter code with the fnet, so the vector starts with 10, 0, 0, and then in order to find fgrav, then we just use the negative balls or washcloth's mass and multiply it by gravity. And then in order to find the ball's velocity as it's dropped, you have the velocity plus the force of gravity divided by the mass, and we multiply this by delta t. And then here's my GlowScript code for gravity and drag. As you can see, the fnet changed. Here I have the vector at 0, and then I have the negative ball's mass times gravity plus b times the ball's velocity squared, and then also have 0 as our z component. And then further down, you have ball's velocity is equal to the ball velocity plus fnet divided by the mass of the ball times delta t again. And here is the computational models all overlaid. So in the dark orange, you have the model that involves drag and gravity. The gray is just gravity. And then the light orange is what we observed just by manually tracking the coordinates in Tracker. And then some possible errors for this lab is I had to manually track the object in Tracker because the object was blurry between frames. So this could lead to multiple errors involving placement replication of the object. So whenever I was trying to measure where it was at, I may not have had the cursor in the exact point I had it whenever I was measuring beforehand. There also could have been rounding errors with the math, whether it be whenever I was recording placements from Tracker or whenever I was recording the data from GlowScript. I also might not have fully released the washcloth with no effective friction, so I may not have fully opened my hand to where the washcloth dropped with no resistance, and that could have impacted how gravity pulled the object down. So some further questions is which models predict terminal velocity? So the model that accounts for drag is most accurate predictor of terminal velocity. This is because terminal velocity happens when the force of drag pointing up has exactly balanced the force of gravity pointing down, which would best be shown with a model that does take into account the drag force. And then what if the object was initially thrown down? So since initial velocity does not affect terminal velocity, only drag and gravity could change the effect of our terminal velocity. However, if you do increase the initial velocity, the object will just reach terminal velocity quicker.